desk.
Awesome.
So I'll be joining you today as well.
Awesome.
All right. So if you can't see my screen, holler out. I'm really looking forward to presenting today. Had a lot of fun putting together this content. It's something that I'm quite passionate about. Something that we talk about a lot here at HashiCorp, which is just how important identity is within more modern approaches to the ways that we're addressing security challenges. And I'm going to talk about it in the context of how we tackle application and data security, and roll through this today. Got quite a bit to cover off. Hopefully we get through it all in 45 minutes. I may talk a little bit fast. We'll see how we go. But first of all, I wanted to talk about why identity is so important. Effectively sort of delving into a little bit of how and why the threat models have changed and why identity has become more important for us to all look at. I'm going to spend a little bit of time looking at proof of identity. I like to, when I'm presenting, talk a lot about like the things that I understand well and then try and transfer those principles. So we're going to take a look at human identity, what we've done over the years with regards to that, and then start transferring that across to when we start looking at things like machine to machine communications, what we do around identity-driven access, identity-driven authentication, what happens and what changes when we start adding people into the mix with regards to that. So you've got humans wanting to communicate with machines. And then finally, we're going to take a look at it and go, okay, well, what is this, how does this potentially impact as well our views on the way that we look at data encryption? So I really hope that it's of interest to you all. I'm not quite sure how we handle questions, but I did see that you've got some time there at the end of the chat. So I guess we'll just take those as they come. So first of all, getting into the importance of identity and why it is so critical. And if we look at how we've traditionally treated security within sort of that data center paradigm, we've taken a really strong castle and moat approach to it. We've built up the walls, we've put in place a drawbridge, we fortify it and say, look, we're going to put a firewall here, we're going to put WAF, we're going to put SIEM, and we put these controls in place. Because what that allows us to do then is take on a paradigm where we say, well, with all the controls that we've got in play, if you're on the network, then we're going to assume that we trust you and that you're a trusted individual. And if you're coming in from the outside, then inherently you're actually untrusted. And if we look at how this sort of starts to play out in practice, let's imagine a scenario where you've got a team who's trying to launch a new product, bring something to market. And so they build out, their application, they put in place the infrastructure, and it's the day before go live. And they realize, much to their dismay, that they've forgotten to put through a change request to say, hey, we need this, front end of our new service to be public facing. Otherwise, we're not going to be able to get anybody onto it. And so, they pick up the phone, they talk to probably some folks who are on your teams, and they say, look, we have to have this go live tomorrow. Can you just unplug the network cable from our front end web server, put it around the firewall and just plug us directly into the internet? Now, first thing they do is probably hang up the phone, right? As crazy and as silly as that idea is, what they would probably do is say, look, we've got a change process that we have to go through to verify this. Now, if you can get the approvals, we can get this done in a week, but a standard change typically takes us 4 weeks to process. And of course, that forms like a level of conflict. How do we go about resolving this? Now, I would suggest that most of you probably have also started investing in the public cloud. And so what we see teams doing is going, all right, well, surely it's faster then. Could we just address this if we tried to solve this in the public cloud? And so they redeploy their front end out into the public cloud and they go, all right, what is involved with getting this externally facing? And unlike your data center, the controls in the public cloud are all logical in nature. You can make an API call and say, can you please attach a public IP address to my instance? And your public cloud is going to come back and give you like a 200, okay, everything's fine. But everything's not really fine because they haven't implemented any of those security controls. And so, by, point of misconfiguration or through maybe a zero-day vulnerability, the reality is that at some point in time, what's going to happen is you're going to have somebody untrusted, come through there. And as a result, because we look at connecting those front-end systems of engagement with our back-end systems of record, the assumption has to be extended that, hey, well, we now need to start thinking about this idea that we potentially have to defend against untrusted people on network. And so the only way that we can do this is to take advantage of identity and ask both people and systems to prove who they are before we give them the ability to access much of anything. And so this is that sort of, shift really that we've seen with regards to our security posture. And in large part, it's come through from the clouds. But I think if we, can be honest about it, and if we look, we've seen misconfigurations within our private data centers for, over the last years as well. So this model is definitely applicable regardless of whether we start looking at it from within the context of public cloud or within the data center. All right, with that, let's get into the idea of identity. Now, the example that I love to work through is, how I go about opening a bank account. When I walk into my local branch and say, hey, I want to open an account, by default, they don't just go, sure, no worries, we can do that for you. No, by default, they go, okay, before you can do that, you need to prove who you are to us. And the way that we go about proving that is by giving them some kind of proof of identity. And, I think each country probably has their different controls and different systems, but they're largely consistent, I think, in terms of how they approach that. And so, the passport is a particularly strong example of a proof of identity. And the thing that I find really interesting about this is that when you look at a passport, it contains information about me. It's got my full name, it's got my date of birth, it also has the place that I was born, but it also has information about itself. And that's because not only is this identity, not only is this document something that is meant to be used to prove who I am, but it also in and of itself needs to be verifiable by the people who've issued it. And so you see things like document numbers, we see things like expiry dates, they don't last forever, that are specifically related to the proof of identity as a means of being able to verify that. If we look again, another example here, when we break it out for a driver's license here, there's information about me in the context of my name, my date of birth, my current home address, and there's also the information, again, about the document itself, so that anyone who wants to take advantage of a driver's license as a proof of identity can go back to, in this case, the New South Wales government and say, hey, here is the card number or the document number. It says it was issued to Grant. Can you please verify this here? And then off the basis of that, they trust the other information about me that's contained on the driver's license. So I found this kind of fascinating, and I thought, okay, so how do we tackle this when we start looking at it in the context of systems, right, and machines within the data center, within the cloud? And really, there's sort of two, there's probably more than this, right? But I think in terms of breaking this down into a coarse-grained conversation, there are really two separate areas where we start looking at the idea of, okay, how and where do we use identity and where does it start to come into play? And the first of those is within the context of network connectivity, right? And how we look at firewalls and how we look at trying to prove identity in terms of, what you should be able to access. And the second level is more like at that application level. When we start getting into, authentication, auth-n, auth-z, it's largely down to this concept of, okay, are you presenting me with a set of credentials that are also something that says, yes, we should be able to connect to a target system. So I want to break those up into two different discussion points. And I want to talk first of all about this in the context of the network. So when a machine says to a firewall, I want to connect to that target service, what do they present as identity matter? Well, they present IP addresses. And, this is interesting. And the last time that we saw an address that we spoke about within this presentation, it was within the context of my driver's license. And you can see here that what's being presented is just a piece of information, one single attribute about the workload, right? There's no way for the firewall to verify, hey, who issued this IP address, right? There's no way to check and say, does this IP address actually match up, because the address is just a function of the identity. It's not any kind of proof in and of itself. So it's a very, very limited kind of model that machines actually use often within our data centers to try and say, here's who I am. And of course, you would have all seen this through things like, spoofing attacks and all the rest. The IP address itself is pretty poor man's way of identifying workloads. So that being the case, what is the right way to prove machine identity? Now, if we look at, the public cloud has introduced a bunch of amazing, amazing capabilities. But, to my mind, the thing that they have absolutely transformed is this concept of identity. Because every time a workload is spun up, right, regardless of whether we're talking about AWS or GCP or Azure as, the public cloud providers, or we talk about Kubernetes as, a scheduler and an orchestrator, or we talk about, GitHub in terms of GitHub Actions and how it sort of spins up compute to perform certain functions. Same thing for GitLab. The reality is that when they spin up those workloads, they inject an identity document into those specific workloads. Now, not only do they inject an identity document, but they also expose then their own identity API that can be used in order to verify this, this concept of, hey, I've got a workload that's presenting this document as proof of identity. Is this legitimate? And you can check the claims and some of the metadata associated with that to actually verify that the machine is who it says that it is. And I think that is probably the most powerful thing that we've seen brought into public cloud. Now, there's one other icon on there, sort of up at that 12 o'clock point, which I haven't spoken about, which is public key infrastructure or certificates. And that is something that goes back beyond the introduction of the public cloud providers, right? We've always had this idea of root of trust coming from a root certificate. We've had intermediate certificates. We've had the ability to revoke. We've had the ability to look up and query, is this certificate legitimate? And public key infrastructure is challenging to maintain, but it also brings some really interesting benefits to it. So when we looked at the idea of machine identity and securing workload communications with Consul, we looked at public key infrastructure as a way of tackling this process. So if we look at how this works, again, when workloads are spun up, they're actually going to register into Consul, and they're going to assert basically that their identity is largely tied to a service name. So in this case, it could be web or API, and you might think, hey, this sounds relatively like the idea of DNS. And at a certain level, it is, right? It's the idea of how do we register service names and have them resolve to the services themselves, as opposed to having host names resolving to IP addresses. Similar in nature, these kind of ideas. Once that registration process completes, Consul will basically push down a certificate that says, this is, web.my.hashicorp.consul, just as a sort of domain name. And that ties into the SPIFFE standard in terms of understanding the identity of the workloads in place. Now, one of the big things that we then get is the ability to say, okay, I am going to start presenting my certificate as a client to you as the server. And, traditionally, when we look at the way and the threat models that we were sort of trying to deal with, we were always concerned about server side. When you log into your bank account, is this website presenting me with a legitimate certificate so that I have confidence that I'm connecting to it? Now what we're seeing is actually server side want to know that the clients that are attempting to connect to it are actually legitimate and are who they say they are. And so, this shift in paradigm has led us towards the idea of clients needing to present certificates. So how does this tie back to the idea of then the firewall model? So in the same way as we would traditionally look and say, IP address A is allowed to communicate to IP address B, in this case, each of these services are going to be in continual communication with console and saying, okay, which services as represented by these particular set of certificates are allowed to communicate with me. And off the basis of that, and if it is actually approved, then what we see is the API service in this case is going to present its certificate back, and that connection is actually upgraded to mutual TLS. So we're getting not only the idea of how can we leverage identity as a mechanism to verify connectivity, but we're getting the added benefit of mutual TLS, which is, to my mind, a great way to provide us with an additional security control if we're considering attackers being on network. All right, so that's our first, again, just recapping, we were going to look at the idea of network access, and then we were going to look at the idea of how do we handle credential management, right? Those two separate parts. So let's shift into the idea of how we deliver identity-driven authentication. So again, what I'd like to do is just look at what we do for people or humans, and then start transferring that again back to what we do for machines. So on screen, we've got a visual, and I like to think visually, so I apologize for all the pictures. I'm used to doing whiteboards and sort of drawing my way through my thoughts. This is how I like to sort of work through ideas. The idea of human authentication and sort of being able to prove cryptographically who you are is, I think, a pretty well solved domain at this point in time. You've got some really strong contenders out there, whether it be leveraging Okta or Auth0 or Azure AD or Google Workspaces or GitHub. There's also many others. I apologize for not having those on there, but that whole process of being able to say, hey, I'm going to present a username, I'm going to present a password, I'm going to present some additional authentication matter in the form of maybe a YubiKey or an RSA token, maybe Google Authenticator or Okta Verify. This process has been pretty well understood for a little while now, and it doesn't matter whether your user, as it sort of shows on screen here, is coming into your central identity platform or going direct to an app and getting redirected back to that identity platform. The idea that you have a really strong central model for authentication and the process there is actually time bound and expires and access has to be reissued is pretty well, I would say it's not quite a standard in that official sense of the word, but it's something that we all accept as the right way to do human authentication. And I find it really interesting again that we have this same kind of concept of there's someone who issues the credentials that we can actually go back and verify those with again, whether it's leveraging something like SAML, OAuth or built on top with OIDC. When we start looking at machines, we're probably going to start talking about, JSON Web Tokens or JORTs. Those capabilities make sure that you have a really strong model around how authentication happens between humans and applications. So once again, let's take a look at how we can take a model like this and apply it to machines instead. As you can see from this picture, we've spoken about that network element, but how do we introduce credentials between, say, an API tier and a database? Typically, it's just a simple username and password that we've embedded maybe into a configuration file, maybe we're using environment variables. But as you can see, once again, there's no issuer that we go back to and say, hey, did you give these credentials to this machine, or should this machine have access to these credentials in the first place? So we're losing one of the strongest parts of this. The second is that there's not inherently any mechanism to expire and refresh those credentials. And, I think when we start looking across, the broad fleet of services that you're probably responsible for, if we said it takes 15 minutes to rotate the passwords on every single machine, and you said, hey, we've got about 20,000 machines in total, I can't do the maths on the fly there, but let's just say it's a very long time and you'd be employing people full time, you'd probably be introducing a level of risk with regards to what happens if you change the password and there's shared credentials. What's the impact going to be with regards to that? So how do we tackle, again, this problem from HashiCorp's perspective? So we take advantage, again, of that same model around machine identity. So when machines come online, they can authenticate into Vault and pass through that matter, whether it's from AWS or from Kubernetes or any of those identity providers, at which point in time they will be given basically a policy that says, here are the secrets that you have access to. Once they've retrieved those secrets, they can then authenticate against the target system that they're trying to connect to. So that's kind of nice. You know, that's helping us deal with the idea of verifiable identity and controlled access to sets of credentials. So a big tick on that one. We still have the username, the password, that's all okay, but expiry. We're still not addressing that idea of long-lived credentials. And again, if we assume that we've got attackers on network, it's probably just a matter of time before someone gets their hands on credentials and is able to exfiltrate data out of your network. So let's again look at how we reframe this and, you know, evolve that Vault journey and deal with expiry. So same authentication method as before, but in this case, Vault is going to reach out to the database. So I've shifted from talking about targets to make it to this database and make it a little bit more specific. And it is going to reach out and it is going to basically inject a set of data into your database. And if we take a look at the policy, it's going to contain three things that you're probably interested in as security professionals. First of all is time to live. So it's not quite injecting that into the database, but it's worth sort of talking about this conceptually, that Vault basically manages this idea of a time to live around the password credential generation, revocation, and recreation. So credentials could exist for as short as 30 seconds. It could be out to 30 days. It's up to you to determine, again, what your sort of window is with regards to that. We can also support templated usernames. That's not a security control per se, but it allows you to correlate when we start, you know, going through your SIEM, which credentials have actually been created by Vault and how many credentials, you know, which credentials have been used, and just correlating that idea between, oh, yep, that's a Vault generated credential. We can see that it's being used for these particular sets of operations. And as a result, it was also requested by these sets of machines. So you're getting some really strong correlation there. A password dictionary. Now, if you're using short time to live credentials, complexity maybe isn't a massive concern, but maybe you're not quite ready to move to this whole idea of dynamic credentials. Maybe you just want Vault to be renewing or rotating a static account, but just changing the password on a semi-regular basis for you. So that is where password dictionaries really start to come into play. The final one is the idea, of course, you don't just create a database user, you have to deal with, you know, authorization. What should this role be able to do? So in database language, we talk about grants. If we're talking about public cloud profiles, then we're talking about IAM. More generically, we could talk about these as roles. But basically, you're able to say, oh yeah, this machine only has the ability to request credentials that have read access or only have write access. So you start to get some really fine-grained controls in terms of managing blast radius and rotational models for all of that. Of course, once that's created, then your machine is given those credentials back and it is able to use those to connect to your target database system. So it's a really powerful capability that I think addresses that problem around time to live. How do we introduce short-lived credentials? And you can just quickly call out, this picture here is largely showing the idea of just, hey, you generate it and there's some of the detail missing. Yes, there are SDKs so that you can do application native Vault integration, but if you've got, say, a commercial off-the-shelf application, typical COTS apps, and go, oh, how do we modify this? You can take advantage of the Vault agent, which can render those secrets down into config files or environment variables, and then issue a command to restart services so that they can then inject those as part of that database connection. Now, it is worth calling out, I've used the database as an example, but there's a vast ecosystem around the Vault Secrets plugins. So you could be dynamically generating AWS credentials on the fly, Azure AD credentials, service principals. You could be doing service account check-in and check-out from Active Directory, or generating those again as dynamic credentials. So really, really powerful capability as far as that goes. Now that's all as far as like that sort of machine to machine model goes. But what happens when we introduce people into the equation? So again, I'd just like to sort of compare and contrast how we've typically approached these kinds of problems. And I'm taking the most extreme variation of this, right? Which is if you've got somebody on call and they need to connect to a target system within your environment, then absolutely the first step that they need to do is connect to a VPN. Challenges with VPNs, look, you're either managing again a separate set of credentials rather than going through your central identity platform, or maybe you've got a certificate-based model which needs to be managed by a central help desk and push those out. It works, but there is sort of a level of overhead there. Once you're on the VPN, that places you on the corporate network, but typically you need to hit a jump box in order to get into the target network that you want to actually gain access to. The problem, of course, is that that target network probably doesn't just contain the system that you want to gain remote access to, but it might also have access to some more sensitive systems. So we need to start putting in again firewalls, falling back to some of those IP-based controls in order to give you access to the target system. Oh, and of course, we still need to retrieve credentials to be able to hit that target. So, talking about this from a user perspective, it's probably, I'd call it challenging, I guess. From a security professional perspective, it's a slightly different angle, which is, if we want to check or verify who has access to that target system, we need to look in quite a few different places to be able to correlate that. We need to say, okay, who's got access to the VPN, who's got access to the jump box, assuming that jump box rule is in play on the firewall, we need to check that and verify it, and then we need to look at credentials. So you're creating like what I would say is like this span of control issue, whereby you need to be interrogating multiple systems in order to get answers to what should be a relatively simple question. And if we talk about databases as we did in the previous example, they are not highly dynamic in nature. So we're not going to see lots and lots of those come and go. But what if the target that you needed to hit was actually a Kubernetes pod, something's a bit more dynamic? What if it was from an auto-scaling group in AWS or a managed instance group in GCP? So those things scale in and out. Things like IP addresses tend to change. And so, your firewall rules may not actually, allow this. So there's challenges from the user perspective, there's challenges from your own security audit perspective, and then there's challenges from an operational perspective. So let's take a look at, again, how we've looked at this problem again and said, how can we again use the cornerstone of identity to address these challenges? So to begin with, the same picture, right? And I probably don't need to apologize for showing the same picture, because the idea is we keep coming back to this same model of leverage your central identity provider as a means of controlling all of this. So when your users come and they're trying to come in to connect to their target systems, instead of having VPN credentials or certificates that they need to actually manage, they're going to hit Boundary, which is going to redirect them into your existing identity provider. Now, at the same time as that is going on, Boundary is sort of polling your infrastructure, right? So it's keeping an eye on everything that's in existence based on, again, things like tags, and then aggregating those into sets of systems that individuals are going to need to be accessing, right? Now, if we think back to sort of the console talk track and how we were looking at the idea of service to service communication, if we even think about the challenge previously that I listed, where you land on a jump box and as a result you have access to a network, and I said, hey, that's bad. Just because a host exists within Boundary doesn't mean that you can just, get access to it. What you need to do is specify targets again. And, I think this is a fairly important distinction, because when we look at this and you say, hey, I probably want my DBAs to be able to have direct access to maybe Postgres. I don't want them to be able to actually SSH onto the target system, right? There's kind of these different sets of controls. Conversely, you might say, yep, operators can SSH in because we want them to be able to perform a different set of things, but maybe we don't want them to have the ability to sort of jump in and access SQL. Now, credentials, of course, become part of the challenge of this whole process. And if you remember, we've already sort of tackled the idea of what can we do as far as machine-to-machine credentials go. So you can bring your own credentials, absolutely, and you can maintain those and keep using those in a static fashion. Or the alternative is to say, hey, I want to introduce Vault into this equation. And so as a result, when your users come in, they log into Boundary and they see the catalog of systems that they actually have access to. If they say, hey, I want to gain access to something, then Boundary is going to reach out to Vault and say, based on this user, based on the groups that we've sucked in from your identity provider, they should have access to be able to connect to SQL out on this particular target system. Can you help us out with a set of credentials? Vault reaches out again, just as we looked at previously, generates those credentials on the fly, passes those back in to the session, right? It doesn't pass it back to the user. It injects those transparently into the session so that the user can then gain access to SQL, but they don't have access to SSH as part of that process. So again, this is like it looks kind of complex on the screen because there are a few moving parts, but the end experience to the user is that they hit Boundary, they see what they have access to, they double click in their client, and it just seamlessly connects them through. From your perspective, again, and from the security team's perspective, attestation and access becomes really easy to verify because we can simply query the audit logs of Boundary. It's going to establish, what groups users are actually members of out of your existing identity platform, and it's going to log each and every one of those connections so that you can really understand quickly and easily what users have access to. All right, I'm just looking at the time here. I don't have a lot of time to kind of jump through data encryption, so I'm gonna tackle this relatively roughly. My apologies. Maybe we can come back and talk about this more a bit later. But when we look at data encryption, the question that I want to ask is, what are we protecting? And what I've seen over time is we've kind of started to correlate data with database almost. At some level we say, oh, we need to protect the data which is residing on a set of disks. And so we bring in a HSM and we say, all right, cool. What we're going to do is make sure that the disks associated with the data of the database are going to be encrypted. And what that protects us from is definitely, somebody walking into your data center, stealing disks, trying to rehydrate those and gain access to data. It's going to protect against things like backups. If somebody gets their hands on your backups, attempts to perform a restore at that disk level, then without the HSM, they're not going to actually be able to read that data. But if we think about things being on network, if we think about your attacker again being on network, the type of threats that we need to protect against extend beyond sort of those physical controls. What do we do if somebody is on disk? If somebody is on network and performs a select star from table X, suddenly they dump the data, and your HSM has very helpfully decrypted, because it is transparent disk encryption is also transparent disk decryption. And if you come through a trusted API, then you're going to get access to that data. So if we look at the way we handle this again with Vault, we've got that same identity-driven model, and you could send through basically a set of clear text to Vault. Now, unlike the model around key value secrets, we're not going to store the data. Vault is not there to actually store your information. So what we do is take that unencrypted data, send it back as ciphertext, and allow you to then write that through to your database. This is providing you with field level encryption, right, as a capability. We support format preserving encryption, so you don't need to change database schemas if you wanted to take advantage of this for something like credit cards, date of birth, etc., where you would get a string back typically. We can also extend this out and perform tokenization. So if you wanted to be sharing data sets without actually sharing the direct data, then tokenization gives you a strong capability. Now, this is not to say you should throw away your HSMs. This is not to say throw away your controls at that physical level, but especially when we start looking at things in the cloud, we need to really understand, what our controls are, what the cloud service providers' controls are, and how we can sort of layer these multiple defense strategies in play to make sure that our data is actually protected. So with that, I'm going to wrap up the presentation, just say thank you very much. Please, if there's one thing that you take away from this, and it's not to do with HashiCorp's products, please, please, please look into that idea of how can we leverage identity as the foundation for any security controls that we actually put in place going forwards. Thank you.
Great, Grant. Amazing session. You still have 10 more minutes if you want to leverage and expand on the encryption part you were talking about. Otherwise, we can get into Q&A. Totally up to you, how you like.
Yeah, let's jump into Q&A.
Okay, awesome. So guys, if you have any question, please raise your hand. I will unmute you and then you can ask your question live. Okay, so let me allow Mike. Venkat, let me see, Venkat. Yeah, Mr. Raju, please go ahead, ask your question. It was not appearing correctly here. Go ahead, please. You can unmute yourself now.
Yeah, thanks everyone for unmuting.
Sure.
Yeah, so two questions. One, while we do our the API security measures, we generally use our hash assaulting mechanism to secure the APIs which are in use. Do you have any other mechanism which you can suggest for the better security? That's one. The second one is when we do the data encryption using, I could say it as the data in transit. Especially everybody, you start using the TLS and other parameters to use the certificates or kind of thing. Do you suggest any other attribute where we can use it as the security measure?
Sure. So we've got. Let me answer the in-transit thing first, and then we'll come back to your first question because I just want to catch that again. Look, I mean, I think there's, gosh, I think realistically, if you could implement mutual TLS across the entirety of your network, you'd be in a really, really good place. And I think the big challenge that everybody faces is that, the management of PKI and the actual process of issuing certificates and, treating them in the same way as I did sort of suggest elsewhere, right? Like long-lived certificates, that's going to be a problem. But as you move to shorter and shorter lifespan certificates, you just increase the operational overhead so much. And I think this is why, like, bringing a level of automation in, and whether it's through, something like Console in order to, provide that as sort of mesh capability, or, even if you just said, look, we want Vault to help us in terms of rolling out certificates across our fleet. We've got a bank here in Australia who has in the vicinity of 40,000 certificates that they're managing. So if you can think about like what that looks like, I'm not sure what your scales are and I won't ask you to share, but even if you could just find a way to roll out certificates and then leverage some other technology in order to provide you with secure communications, I think you'd be in a really, really good place. And then as far as the first question, so you're asking about in terms of APIs, and the first part of your question kind of dropped out for me. I think you were asking about leveraging SHAs.
Yeah, so my question is, when we do the API security, we use hashing algorithm or the salt mechanism to secure the APIs. So do you suggest any better version or attribute you suggest from your side, from the industry standpoint?
No, absolutely, same thing. So when we do our encryption, we are still leveraging standards, right? So we are still leveraging in fact, I'll probably share some stuff that can come out after the session if you like, but we're not doing any kind of clever black box encryption on our side. So we're taking advantage of all of the standards. We leverage different types of keys for different use cases. We allow you to do self-generated salts or nonces along the way. There's nothing uniquely special about how we perform that encryption. It's just that idea of, how do we give access to that, and how do we make it sort of a developer-friendly consumption model, but allow security teams still to control what that process looks like and how you go about performing things like keying and rekeying.
Yeah. All right. Thanks. Thank you very much. Thanks, Blas.
Great. Sounds good. Virajji, go ahead. Ask your question now.
Just 2 or 3 fundamental questions. I'm audible, right? Because
yeah, you are audible.
Thank you. So my question was, your solution works equally and seamlessly across on-prem and cloud instances. That was question 1. And question 2, what really differentiates the encryption you're talking about? Because backup solutions do offer encryption capabilities themselves. So is there something specific you want to highlight on the HashiCorp side? And
Sure.
a related question also on the vaulting. Is the vaulting different from what Oracle Vault offers for databases, or is there something different you have in store?
Sure thing. So to answer the first question, absolutely. So one of our mantras here at HashiCorp is workflows, not technologies, which is very much about the idea that it's important to have capabilities regardless of which platform that you're working on. So when we talk about Vault, we've got people using it on Ali Cloud, on premises. They've got it deployed on Kubernetes, GCP, AWS, Azure. I could sort of go on, VMware as well, of course. So yes, absolutely, it works across all of those platforms. The second question that you asked, and I didn't quite write it down. What was the second question you asked? The second question was whether there was anything special about it versus the backup vendors, right? So I think there's 2 elements that come into play. So number 1, I would say Vault, first of all, supports KMIP, right? So if you wanted to leverage it as a mechanism for performing standard encryption operations sort of at that database or disk level, then Vault absolutely can do that. I think where it starts to become more useful is if you're concerned about the data that's being stored within the database, because I think if you've got somebody and the sort of the things we don't like to think about, but that we do need to think about are what happens if you've got a disgruntled employee? What happens if a happy employee is compromised just through interactions with another individual? You've got to be able to say, well, what protection do we have in place if somebody with appropriate permissions was able to effectively log into that database, download a set of content, and then share that or exfiltrate it in some way, shape, or form. The difference with Vault is because we're performing field level encryption, it's actually within the database itself. So someone would need to, basically dump the database. They would then need to force a secondary compromise to Vault to be able to send the data to get it decrypted and remain on network for the entirety of that process, right? They can't ever exfiltrate the key from Vault. We don't allow exporting of the key in that fashion. So it's much more granular in terms of that level of control. So I wouldn't say it's going to replace anything that you're doing with a backup. So please don't take that away from this conversation. It's just looking at a different attack vector and how we can provide a different level of security and prevent that kind of threat from occurring. And then the final question I think you were asking, so I am not familiar personally with Oracle Vault, so I won't talk about what they do. I would hazard a guess that it is probably a KMIP-based encryption capability. So there's no difference in terms of functional capability there that I would say that you're getting from something like Vault versus something like the Oracle Vault solution.
Very well, thank you.
Great. Last question. Gunjan Bhai, go ahead, ask your question now.
Thanks, Vikas. Grant, thank you for a great session. My question is around the vault. So, when a resource or the requester really asks for the permission from the vault to really get access to database, right? And the vault really plays a role of providing that access and ensuring the credentials are given or the authenticators are given. I'm more concerned about the security of the vault itself. How secure is that? Just want to know that.
Yeah. Can I say very and leave it at that, or no? Look, it's a very good and valid question, right? Like if we're saying, look, place all of your crown jewels in Vault, it becomes like a highly valuable target. So when we talk about the way that we go about forming the cryptographic barrier for Vault, you can back that with an existing HSM, right? So if you've got existing HSMs in your data center and this is a use case for that, then that's fine. If you're deployed in the public cloud, again, cloud HSMs, you can also back it with just standard KMS out of the public cloud providers. But it is safe to say we've got this in use and we've got some very public references about very large scale and quite sensitive customers taking advantage of Vault. So yeah, look, it's, we recognize how much of a privileged position that we're in when people take advantage of Vault and just how careful we need to be. So to date, we've been very, very lucky with regards to lack of compromise.
Okay, so the answer is very, right?
Yeah. Yes. Absolutely.
Thank you.
Great, sounds good. I don't see anybody else has raised hand. So perfect, great session, Grant. Last couple of things, guys. If you want to download your participation certificate that looks something like this, I'm on unmute, right? Yeah. So what you got to do is go to EliteCISOs website, click on events, click on upcoming events, click on CPE certificate, and then put your email address, put your full name, and then the password to download certificate is Happy Holi, right? So Happy Holi, everyone. Tomorrow is Holi festival in India, celebrated mostly in the northern part of India. So that's what the password is, Happy Holi. And once you are here to download your certificate, you might want to register for next week's session. As I mentioned that every week on Thursday, we come out with different sessions. So next week we have a session with Sophos. And very interesting topic around MDR, XDR or EDR. I mean, these three-letter acronyms keep coming all the time. So we'll try to understand from Sophos perspective what they have to talk about MDR, XDR and EDR. And I believe Philip is also joining us from Australia next week as well. So you can just click over here and register for this session as well. Apart from it, you might want to consider joining a very exclusive PCI DSS training we are planning. It is on 9th April, Saturday, and this will be a 6-hour weekend session. And the training will be delivered by Swati Anju Arya. She is well-known expert in PCI. So registrations are open. We will take about 20 registrations. I think we already have 8-9 registrations. So if you want to join this, please go ahead and register for it as well. It is highly discounted for Elite CISO members. Okay, guys. So that's about talking about the events, the current one and the next one which is coming. Some people were asking about the recording. So guys, all the recordings go under events, past event section. So we take about a week to upload the recordings and all. So all the recordings from the previous sessions, they are available over here. So you can simply go to this section, click on play, and then you can go through the trainings as well or recordings as well. Now, last but not the least that everybody is waiting for is Wheel of Fortune. So as I mentioned previous week that if you register for the HashiCorp session, right, the first 150 people will go in this Wheel of Fortune. So this is the list of 150 people who registered quickly for the HashiCorp session. So I'm going to spin this wheel, and the giveaway is the portable car tire inflator. That's a device that we are giving this time. So if your name comes, go to the chat and say yes that you are there in the session. And Manish Bhai, as discussed offline, please track the chat and see the person whose name comes in is there in the session. So I'm spinning it now. Good luck, guys. Let's see who the lucky one is. So Dr. Chitranjan Kesri from Mumbai chapter. Dr. Kesri, if you are there, please go to the chat and say yes, you are there. I am also monitoring the chat myself. Let's see. I did not see anyone saying yes as of now. Great. Yeah, I don't think Mr. Kesri is there. So I will spin it one more time. Otherwise, if your name is not there, then we move to the next one, and we have 5 giveaways. I will spin it one more time, and in future, if your name does not come or comes, we will count it as the spinned one. Okay.
It looks like he was just a bit slow in chat. There he is.
Let me see. Did he say yes? Yeah, he's there. Okay. Congratulations. You almost lost this spot. Okay, great. Congratulations. Now what we are doing is we are not considering this one. I am going to remove this now. So the first one is gone out of 5, right? So I'm going to delete all these entries. And now I am going to add the people who liked the post on LinkedIn, right? As we mentioned that if you like the post on LinkedIn, we will put only those people in the next 4 giveaways. Okay, so about 97 people liked. So you can see how better the wheel looks now. And out of 150, we had 1 giveaway. Now out of 97, we have 4 giveaways. So your chances of winning is much higher when you support EliteCISO, guys. Come on. So I'm going to spin it now. And this is Bhavesh Kumar Pandey from Delhi chapter. Bhavesh, if you are there, go to the chat. I will monitor it next. Okay, the second one is gone. I'm spinning for the third one now. And the winner for the third one is Preet Bhai from Delhi chapter. If Preet Bhai, you are there, go to the chat and say yes. Now I'm spinning for the fourth one. Great. Manoharan P, maybe from Bangalore chapter, I believe. Manoharan ji, if you are there, go to the chat and say yes. Spinning for the last one now, guys. Stay tuned. Lalit Mohan Shah, very nice. So Lalit, if you are there, go to the chat and say yes. I think I missed by just 1 point. Otherwise, my name would have come. Great. So that's about it, guys. For next week, again, if you register, if your name is there in first 150, we will have again put your name in the Wheel of Fortune for giveaways, and we'll pick something, some unique gadget. Now, next week, apart from this session on Thursday, on Tuesday evening, also we are doing a session around Women's Day, International Women's Day celebration. So look after for that. The invite will come. It is still work in progress. So we will send a formal invite for that as well. With this, thank you everyone for joining in. It has been a great session, and thanks Grant. Amazing session. I mean, we conduct these sessions every week, right? And some of the sessions stand out. And this is one of the very interesting sessions that you have delivered. So thanks a lot for that.
Thanks so much. Appreciate the invite. Wonderful to meet you.
Great. Thanks everyone. Bye for now.